Hi, Andy. This is again Dr. C.H. Kiran Kumar dealing you the machine learning part. Today, tree models. How do we prune? How do we prune a decision tree? That is today's topic. What do you mean by pruning? Pruning. What is the difference between unpruned and pruned tree? See, basically, why we use pruning? We use pruning to eliminate the overfitting of data. What do you mean by overfitting? Overfitting. Overfitting means now our target is to predict the correct things. Whenever we say prediction. So when we say our prediction is going to be correct. So if you predict the prediction to 90% level, then we say this prediction is very good. Now we want to eliminate. I don't want to go for 100% prediction. I want to have 90% prediction. So in that case, what I do? Pruning. And pruning means eliminating the class labels or the paths which are rarely come across. Such is called pruning, my dear friends. Pruning, right? Let us see now the pruning. Right, pruning. The operation of merging all levels in a subtree is called pruning the subtree. This is one method. The advantage of pruning is that we can simplify the tree without affecting the choosing operating point. So if we want to communicate the true models to somebody else, this is better. But the disadvantage is we are losing the ranking performance. That is why we have gone for what is called reduced error pruning. Reduced error pruning. See, one popular algorithm for pruning decision tree is reduced error pruning. Reduced error pruning. What we do in this? Let us discuss about this reduced error pruning. Now, see, algorithm for reduced error pruning. See, input is a decision tree and labeled set D. Now we will be getting same tree, prune to tree, T dash. For every internal node n of t, for every internal node n of t, internal node, this is internal node, not leaf. This is internal node. For every internal node of t, starting from the bottom, do Tn is equal to Tn. Tn is equal to subtree of t. This is Tn. This is so this is Tn, my dear friends. This is a subtree. Take Tn. Tn is subtree rooted at n. See, this is how it is, rooted at n. Dn is equal to Dn, labeled. X is belongs to D. A label X belongs to D. X is covered by this n. X is also covered in this E subtree lo kuda X unnadi. If accuracy of Tn over Dn is worse than majority class in Dn, then replace Tn. But this is very important, my dear friends. Accuracy of Tn may be calculated by using Gini index or entropy or something like that. And over Dn, you calculate Dn. Dn means X. So if our TN is worse than, if our TN accuracy is worse than DN, and then worse than TN over DN is worse than majority class in DN, TN over DN, అంటే TN on X, TN on X is worse than majority class in DN, then replace TN in T by leaf labeled with majority class DN. అంటే we want to delete this X label from this TN. So replace TN by T, replace TN in T, replace TN replace by a leaf labeled with the majority class in DN. A majority class DN lo unna majority class to replace cheyi. Then we will get the pruning. This is the algorithm suggested for prune tree TD, pruning of decision tree. Very simple. See, this is the only condition, my dear friends. If accuracy of TN over DN, if accuracy of TN over this X, over this one label, my dear friends, over this X is worse than majority class in DN, and majority class in DN. So only one class of DN is right worst ga unte, then replace TN in T by leaf labeled majority class in DN. So this is the condition. This is how pruning is done. Let us explain what is exactly this is. Now, if you see what is called overfitting, here see, you can clearly see what is called overfitting. Overfitting. See here, if you see here, there are blue are good and red are negatives. Blue are positives and red are negatives. Suppose if you see here, this is the graph, and bad 0.42. For example, first total one, if లెక్కేస్తే 100లో 100 ఉన్నాయి డాట్స్, ఇవి 42 బ్లూ ఉన్నాయి, 42 రెడ్ ఉన్నాయి, మిగిలిన 58 కూడా బ్లూ అనుకుంటే, then bad 0.42 is our percentage, or 0.42 is our percentage here. Now, if x2 is less than 0.4, yes, we come this way. No, we come this way. Now, if you go on, say, ఇలా చేసుకుంటా పోతే చూడండి, see, ప్రతి bad 8%, ఎక్కడ bad ఉన్నది? See, bad is 20%. x1 is 0.41 కంటే తక్కువ అయితే చూడండి, see, 0.41 అంటే x, 0.41 అంటే something like this. .41 అంటే ఇదండి. దీని లోపల ఎలా ఉంది? 0.41 లోపల what is the bad percentage is 20%. Now if you see, x1 is greater than 0.57 and x1 is less than 0.75. See, 0.75 comes over here. So 0.41 నుండి దీంట్లో కనుక తీసుకుంటే it is 8% bad. 8% bad. See, similarly, if you talk about good, see, x1 greater than or equal to 0.47, good గురించి మాట్లాడుకుంటే it is 2%. సో లైక్ వైజ్ ఇట్లా ప్రతి దానికి లేబుల్స్ క్రియేట్ చేసుకుంటూ పోతే అవర్ ట్రీ would become like this. So this is our decision tree. See, if you talk about positives, my dear friends, if x2 is less than and no, the condition is no, then greater than 0.4, then good 0.54, 64%. See, x1 greater than or equal to 0.5. ఇక్కడ 0.5 తీసుకుంటే, see, every branch is given here almost, but ఎన్ని లేబుల్స్ ఉన్నాయి ఇక్కడ? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 labels are there. Total 15 labels are there. 15 labels, my dear friends. So now this is called overfitting అంటారు. This is called overfitting. ఇంకా చేయాలి, ఇంకా ఇట్లా, ఇంకా ఇలాగా, ఇట్లా, ఇంకా ఇట్లా చేసుకుంటా పోతా ఉంటే, సో ఇట్ గోస్ నో. సో దిస్ ఇస్ హౌ ఇట్ గోస్. ఇంకా కర్వ్స్ కనుక చూపిస్తే ఇంకా క్లారిటీగా అర్థమవుతుంది. దిస్ ఇస్ కాల్డ్ ఓవర్ ఫిట్టింగ్ అంటారు. నౌ హౌ డు వి సాల్వ్ దిస్? Pruning. By using pruning, we can solve this. See, this is our overfitting model. Now, by using pruning, we reduce to this part. Now, definitely, everything is not covered, my dear friends, here. 99%, if you see here, children, 99, see, x2 is 0.4 less than 0.5, x1 is less than 0.5, x1 is greater than or equal to 0.5, x2 is less than 0.4. That's it. See, simple. This is x1, this is x2. సింపుల్ గా ఈ విధంగా కనుక చేసుకుంటా పోతే x2 0.4, చూడండి, x2 0.4, దిస్ పార్ట్, ఇదిగోండి ఈ పార్ట్ లో చూడండి, యూ డోంట్ హ్యావ్ ఎనీథింగ్, చూడండి, యూ డోంట్ హ్యావ్ ఎనీథింగ్ పాజిటివ్. సో బ్యాడ్ ఈస్, see, 20%, 0.00. సో దిస్ ఇస్ హౌ. నో, ఇట్లా కట్ చేసుకుంటా వెళ్తే, సో చాలా లేబుల్స్ వచ్చినాయి ఇక్కడ. సో వీ హ్యావ్ మినిమైజ్డ్ ద లేబుల్స్ అండ్ we finally concluded that we just need 4 labels, not more than 4 labels, and still we can predict the things up to 99% guarantee. So this is called pruning. Pruning antaru. Right, next. Pruning antarandi dinni. This is called pruning. But now, how do you validate this? ఎలాగా వాలిడేట్ చేస్తావు అంటే, స్కోరింగ్, ర్యాంకింగ్ ఎలా ఇస్తావు అంటే చూస్తే, see here, cross validation is a common machine learning technique. Cross validation is a common machine learning technique that splits the data into n non-overlapping groups. That splits the data into n non-overlapping groups and runs n experiments. See, cross validation is a common machine learning technique that splits the data into n non-overlapping groups and runs on n experiments. In each experiment, n-1 groups are used to train model, and the model is tested on the left out group. For example, this is how it is. If this is our total data, right? See, we first divide This is test data. This is all we take. Idemo training data. Idemo training data. This is test data. Right. So by using this train data, we construct an algorithm or we construct a prediction mechanism. Now we do that with this test data and we find the error node. Error ni note chestam. Error ni note chestam. Now we change. Now we change again. Now ఇప్పుడు ఏమంటే ఇప్పుడు దీన్ని టెస్ట్ డేటా కింద తీసుకున్నాం కదా, ఇప్పుడు దీన్ని ట్రైనింగ్ కింద తీసుకున్నాం, దీన్ని టెస్ట్ పెట్టుకున్నాం, ఇదంతా ట్రైనింగ్ పెట్టుకున్నాం. ఇది ఒకటే టెస్ట్, ఇది ట్రైనింగే, ఇది ట్రైనింగే. నౌ we again do the prediction for this test data. Now we get some errors. We just note that error message. Now again what we do is we again change it. See, right? This is over. This is over. Now we go to this point, and this is our test data, and this is all training, and this is all training. Now we again note down the error rate. Error rate. This is how we divide the total given data into 10 parts. 10 parts. Now we assume the 9 parts as test training data and 1 part being the test data. We first fix the first part as test data and the remaining 9 parts as training data. We have already predicted. Now the prediction is applied on this first test data. Now it gives you some error messages. Error prediction, error is our error. We will just note down the error. Similarly, now we go to the 10 parts. Yes, right. We have assumed the first data to be the test data, right? Now we assume the second part as test data and the remaining 9 parts as training data. And we apply the training data to predict the prediction, and we use this particular test data to test on the prediction. This is how 10 times. Now we apply, see, this is what it is, and runs n experiments. In each experiment, n-1 groups are used to train a model, and the model is tested on the left out group. The results are summarized over the n experiments. Very simple. The results are summarized over the n experiments. It gives a mechanism that allows us to test a model repeatedly on data that was not used to build the model. అంటే ఒక మోడల్ ని బిల్డ్ చేయడానికి యూజ్ చేయనటువంటి డేటా మీద మనం మళ్ళీ అప్లై చేస్తున్నాం. దిస్ ఇస్ హౌ ఫర్ డెసిషన్ ట్రీస్ a very common approach is similar to choose the trees with minimum cross validation error. For decision trees, a very common approach is simply to choose the tree with minimum cross validation error. We are now going to construct 10 trees, my dear friends. 10 trees, n trees construct చేస్తున్నాం ఇక్కడ. n trees construct చేస్తున్నాం. ఆ n trees లో ఏది కరెక్ట్ ట్రీ అంటే దేనికైతే ఈ క్రాస్ వాలిడేషన్ ఎర్రర్ మినిమం ఉంటుందో ఆ ట్రీ, దట్ ట్రీ ఈస్ గోయింగ్ టు బి అవర్ ఫైనల్ డెసిషన్ ట్రీ. దిస్ ఈస్ కాల్డ్ decision trees, my dear friends. Decision trees, right? Let us know what do you mean by, right? See, the Gini index of the parent is 2n positive by n and into n negative by n, and the weighted Gini index of one of the children is n1 by n into 2, into n1 positive by n1, n1 negative by n1. This is general formula. So the weighted impurity of the children in proportion to the parents' impurity is n1 positive, n1 negative by n positive and n negative into n1 by n, n1 by n, n1 by n. Let's call this as relative impurity. Relative impurity. The same calculation is for square root of Gini. Square root of Gini. That is impurity of parent is just root of, instead of 2, I'll just square root. Square root of n positive into n negative by n into n. Now weighted impurity of the child is n1 by n root of n1 positive, n1 negative by n1 into n1. Relative impurity, what is relative impurity then? Root of n1 positive, n1 negative by n positive, n negative. So if you see here, right, the important thing to note is that the last ratio does not change if you multiply all numbers involving positive with a factor C. That is, root Gini is designed to minimize relative impurity and thus is insensitive to changes in class distribution. This is very, very, very important. So root Gini is designed to minimize relative impurity and thus is sensitive to changes in class distribution. Whereas others, no, you can also see the same here with a graph, right? This is a graph plotted about, this is Gini, this is square root Gini, this is entropy, this is weighted average, all these things, all, no, okokoti ga manam positives, ikkada positives తీసుకున్నాం, ikkada negatives తీసుకున్నాం, and if a graph is plotted, right, this appears like this. If I multiply 10 times multiply చేసి అప్పుడు గ్రాఫ్ ప్లాట్ చేస్తే, ప్లాట్ చేస్తే దేనికి ఎక్కువ రిలవెన్స్ ఉంది, దేనికి ఎక్కువగా ఇంబ్యాలెన్స్ ఉంది అంటే ఓన్లీ రూట్ జీనీ హ్యాస్ గాట్, ఈ రూట్ జీనీ ఇది ఉంది కదా, ఇది అది ఆల్మోస్ట్ సిమిలర్ గా ఉన్నాయి. మిగిలిన అన్ని కూడా బాగా మాడిఫై అయిపోయినాయి. చూడండి, ఈ బ్లూ లైన్ తీసుకుంటే, ఈ బ్లూ లైన్ ముందుకు వచ్చింది, ఇదేమో వెనక్కి వెళ్ళిపోయింది. ఈ గ్యాప్ తీసుకుంటే, ఈవెన్ ఇఫ్ యూ సీ దిస్ గ్యాప్, ఈ గ్యాప్ చూడండి తగ్గిపోయింది. సో దిస్ ఇస్ హౌ, బట్ ఓన్లీ రూట్ జీనీ is having, that is, a root genes are only that having, no, it doesn't depend on the classifiers. So andukani, so we always go for root gene. So more generally entropy and Gini index are sensitive to fluctuations in the class distribution, but root Gini is not. Entropy మరియు Gini index are sensitive to fluctuations in the class distribution. Class distributions ki ivi rendu, entropy and Gini index are sensitive. And if there is a change in class distribution, the Gini index and entropy are getting changes, but root Gini is not getting any change. So which one should we choose? So definitely the root Gini is the final one to be chosen for training set. For training set, the impurity measures such as root Gini, unless the training set are represented. So normally we use distribution insensitive impurity measure. Distribution insensitive impurity measure such as root genie. This is what we use. This is what we are going to use. Use a distribution insensitive impurity measure such as root genie. Right. Finally, let us summarize. Let's the discussion on tree models so far. How would you train a decision tree on a given data set? Final, how would you train a decision tree on the given data set? This is the question. How would you train a decision tree on the given data set? First and foremost, I would concentrate on getting good ranking behavior. Because from a good ranker, I can get good classification and probability estimation, but not necessarily the other way around. So first, I will concentrate on getting good ranking behavior, good ranking behavior, good ranking behavior, so that it gets you, when you get good rank, then you can get good classification, and the probability estimation also you can easily get. Right. I would therefore try to use an impurity measure that is distribution insensitive. Distribution insensitive impurity measure. Distribution insensitive impurity measure such as root genie. Such as root genie. Generally, if this is not available, when we say it is not available, so generally it is available. When if it is not available, I can't hack the code and I would resort to oversampling the minority class to which will a balanced class distribution. So first thing is getting good rank behavior. Concentrate on getting a good ranking behavior. Getting good ranking behavior. Second one is apply root genie. Don't go for entropy or Gini index models. Right. Third one is I would disable pruning and smooth the disable pruning. Prasthanik disable smooth the probability estimates by means of Laplace corrections. Laplace corrections ద్వారా probability estimation is smooth చేసిన తర్వాత once I know the deployment operation condition ante test data when you have the data, I would use these to select the best operating point on ROC curve by applying threshold. Threshold ante enti? Threshold apply chesi I would then prune away. Ippudu prune away any subtree whose leaves have the same label. So ikkada emante see test data and train data no 10 సార్లు no 10 సార్లుగా 10 షార్ట్స్ గా కట్ చేసి ఒక్కొక్క షార్ట్ 9 షార్ట్స్ నేమో you will be taking it as training data and one shot name you will be taking that as test data. Atla 10 models తయారు చేసిన తర్వాత whichever model gives you the minimized error, that tree is finalized and that is called decision tree. This is how we go with the decision trees.